Good morning. This is Chapter 2, Lesson 4, Proportional and Non-Proportional Relationships. And we're going to begin here on page 147. Here it says, launch the lesson in real-world activity. So in the beginning, it says, Ms. Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Complete the table to determine the cost for different numbers of pizzas ordered. Now this chart should be pretty obvious what you're going to do. One pizza costs $8. If the price is the same, then two pizzas should cost 8 more, or 8 times 2, 16. And then we complete the pattern. 8 times 3, 24. 8 times 4, 32. 8 times 5 is 40. So here we have a relationship between the number of pizzas ordered and the total cost for the pizzas. And as we all can see, there is a pattern going on here. So let's continue to explore this problem some more. Now it says, let's investigate the relationship between the cost and number of pizzas ordered. For each number of pizzas, fill in the boxes to write the relationship of the cost and number of pizzas as a ratio in simplest form. So for example, here we have 16 to 2 because it was $16 for 2 pizzas. If we simplify this fraction, we get 8 over 1. Over here, we have the next order from up here, $24 for 3 pizzas. If we simplify this fraction, and I can divide both sides by 3, we get 8 to 1. Here, I just cut everything in half. I divided by 2. Our third order possibility was $32 for 4 pizzas. $32, 4 pizzas. What's the biggest number that goes into 32 and into 4? Well, that would be 4. So I will divide both the top and the bottom by 4. And I get 8 over 1 again. And finally, my last combination was 5 pizzas, $40. So $40 for 5 pizzas. And if I divide the top and the bottom by 5, I get 8 to 1. So 8 to 1 is this common ratio. That means that it would be on average $8 per pizzas when I'm being charged in every single combination here. And that shows what we call a proportional relationship. When you have the same exact relationship between two things every single time, you have the connection to it is called being proportional. That's how we describe it. So it asks us here, what do you notice about the simplified ratios? We notice that all the ratios are the same, 8 to 1. You can go ahead and write that on your own. Now that we've gone ahead and started with that, let's go to the next page. Now, we are on page 148. And let me go ahead and move to the top up here. And we have the topic, identifying proportional relationships. Two quantities are proportional if they have a constant ratio or unit rate. We saw that in the last example when we had the $8 to 1 pizza ratio that kept, P-I-Z-Z-A, you think I learned how to spell by now, $8 for 1 pizza. For relationships in which the ratio is not constant, this is also just as important, the two quantities are called non-proportional. So when they're not constant, non-proportional. You may have some different ratio. It may be changing in a totally different way. If it was not always the same exact way, it's not proportional. I want to make a little note here. Changes the same way every time. Now that's just one way I'm explaining it. There are some other constraints you're going to need to know, but this is just the beginning one. So let's go ahead and continue now with the lesson. Here, in the pizza example on the previous page, the cost of an order is proportional to the number of pizzas ordered. So we took each cost, and we took the number of pizzas, 1, 2, 3, 4, 5, 8, 16, 24, 32, 40. This is basically the table with the borders taken off, or $8 a pizza. All the ratios above, but ratios, it means all these fractions, because some people are still a little hazy on the vocabulary. These are all ratios. All the ratios above are equivalent ratios because they all have the same value, because they all equal 8 to 1 when you simplify them. That's what equivalent ratios means. So let's go ahead and move down here to example 1. Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. So then first thing you want to do always is when we have a table given to us like this, we always want to look to see if there's a pattern. So obviously when we look on the time, the hours, 1 hours, 2, 3, 4. So those are all going up by 1. Here in the earnings, we have 18, 36, 54, 72. One way to check to see if you have a pattern is to just do some quick multiplication. Ask yourselves, how can I go from 18 to 36? Well, I have to know my times tables pretty well, and I know that 18 times 2 equals 36. Well, if that's true, and the pattern holds, then this next thing should be 2. Well, then that means